I am very happy to introduce you to Margaret Maynard-Reid. She is based in Seattle, and she is a GDE in machine learning. And today she's going to tell us about mobile machine learning, well, mostly focusing on TensorFlow. So with that, I'm going to turn it over to Margaret.
Great. Hello, everyone. My name is Margaret Maynard-Reid. I welcome you to my talk, Machine Learning for Mobile with TensorFlow. I work on machine learning and Android, and I write tutorials and speak about TensorFlow and Android. I also run GDG Seattle. I'm the lead organizer. I co-organize Seattle data analytics and machine learning. So let me click it, share with you my screen. So here's the slides. For those of you who want to get the slide, if you have your computer with you, you can go get it. I have actually made updates, but it's okay. Next slide. So today I'm going to give you an intro to AI and machine learning and deep learning and computer vision and TensorFlow and Keras. I will talk about the overall process, going from data to model to deploy for inference, and then walk you through end-to-end how to go from tf.Keras to TensorFlow Lite to Android. So I want to get an idea of how many people actually know machine learning, so I can...
Okay, I'll count for you. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 15 and a half person raise their hand.
Half the people already have some idea about machine learning, right? And how many people have done mobile application or Android application?
All right. Wow. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 15. Also 15, but I'm not sure if the same 15.
Right. But this will give me a good idea, as I go through the talk of, which area to go in more in depth or which area just like kind of skip through and go quickly. So next slide, please. And next one. So just really quick, we hear a lot about deep learning and computer vision and natural language processing. AI is actually the big umbrella of creating some intelligence with the machines, and machine learning is one way to achieve that intelligence. And then deep learning is a subset. And the reason why I'm trying to make the distinguishment is a lot of times we're also using TensorFlow for deep learning. Next slide, please. The example of the deep learning, one classic example is for image classification. For example, you can classify whether in the picture is it a cat or not. And other examples such as object detection. If you're in a self-driving car, you can detect other pedestrians and cars, etc. But machine learning or deep learning can be used to not only perform these tasks like spam or natural language processing, etc. It can also be used to generate new images, music, as well as art. Next slide, please. So since half of you are new to machine learning and deep learning, I want to share with you how to get started. First of all, you have to pick a deep learning framework. And TensorFlow is one of the most popular framework out there. And then there's PyTorch, Cafe, and Piano. So my talk today is going to focus on TensorFlow, but I also want you to know, TensorFlow is just one of the several frameworks available out there. And you can write the TensorFlow code in different languages, Python, Swift, JavaScript, etc. In last year's TensorFlow Dev Summit, Swift and JavaScript were announced to be available for writing TensorFlow code. But a lot of us is still writing the TensorFlow code with Python. And in terms of the IDE, my example, I'm going to use this thing called a Colab, which I'll go over in details later. For those of you who have PyCharm, you can also use that to write the Python code. And there are different types of neural networks. For example, convolutional neural networks, typically used for computer vision. There's recurrent neural network, used for a lot of use for natural language processing. And earlier I mentioned about generating images, and we use generative adversarial networks to do that. And you notice that on my slide, some of the words are highlighted. For example, TensorFlow, Python, Colab, and CNN. These are highlighted. And because there's so many different choices of doing deep learning, I highlight these words indicating these are more of the focus of my talk today. Next slide, please. So here are some of the machine learning resources. There's lots of resources for you to learn about TensorFlow. And even though TensorFlow is a framework, as you learn about TensorFlow, there's also a good opportunity for you to learn about deep learning. For example, on TensorFlow.org, not only you can find these API documentation, right, a particular API, what it does, you can also find tutorials about computer vision, natural language processing, etc. On blog.tensorflow.org, you can find blog posts, and I've included a link to the TensorFlow Dev Summit videos from last year, which was last March. So in a few months, this March, this year's TensorFlow Dev Summit is coming up in a few weeks. But you can still find the YouTube videos pretty helpful. On YouTube, there's also dedicated TensorFlow talks there in small snippets, very small videos, a few minutes. And then if you go to a seed bank, you will find a collection of interactive machine learning examples. All of them are written in Colab, which, how many of you have heard about Colab?
Okay, maybe just 8.5.
Okay, great. Some of you. I will talk about Colab in more details later. Finally, I recommend this book called Deep Learning with Python. It's written by Francois Cholet. He is the creator of Keras. Even though this book is called Deep Learning with Python, really it's Deep Learning with Keras. So you will learn a lot about Keras. Next slide, please. So here are these model building APIs of TensorFlow. Recently, I've written a blog post on the model building APIs. I will include a link later on, where for those of you who know machine learning already, probably already have some exposure to TensorFlow, some of you probably have written code with the low-level TensorFlow code, which is tf. That star. And then you probably have written code with the layers API, and then tf.Keras, and then there's estimators on the top. So what we recommend for you is to use the tf.Keras to write TensorFlow code. And TensorFlow 2.0 is coming this year, and the TensorFlow team really places an emphasis in trying to make everything streamlined and simplified, and use for everyone to use tf.Keras, whether you're a beginner or a advanced deep learning or TensorFlow user. Next slide, please. Real quick, to talk about Keras versus tf.Keras. Keras remains an independent project, and you can still use the backend like YAML and CNTK, etc. But if you do use TensorFlow itself as a backend, it doesn't make sense to use Keras and the TensorFlow as backend. You should just use tf.Keras, which is the Keras implementation inside the TensorFlow core API. This is highly recommended. Again, I'm highlighting this, and this is what I'm using my example as well. Next slide, please. So here is a brief overview of TensorFlow, and mostly from a mobile developer's perspective, right? Because TensorFlow has a lot of other APIs like TensorFlow, the TPU, the running in the cloud, extended, etc., etc. But from a mobile dev perspective, I'm going to just go over what I think that in 2015, TensorFlow was open source. And then 2016, back then when it first open sourced, I remember in 2016 when I was giving a talk at that time about making Android apps with intelligence, I could barely even try to build the Android app. I had to go download the APK somewhere. That was back in 2016. And then later on, there's TensorFlow Mobile, and the API basically try to make it a bit easier for implementation of the models on mobile. And then in 2017, after 2017, there's TensorFlow Lite developer preview was announced. As of today, TensorFlow Lite is still in developer preview, but it should exit the developer preview soon. I will talk a bit more about TensorFlow Lite later. And also this year, TensorFlow Mobile is going to be deprecated. So if you write code with TensorFlow Mobile, I encourage you to try to move to using TensorFlow Lite. Next slide, please. And next. So machine learning for mobile using TensorFlow, there are lots and lots of different choices, like too many choices. So I look at it for this perspective. One is with MLKit, which was announced in the Google I/O last year, 2018, or without MLKit. With MLKit, you can use the ready-made pair services or a custom model. And then without the MLKit, you just follow the process. You need to collect your data, you need to train the model, and deploy the model for inference. Next. I'm going to just briefly mention it, and this is not the focus of my talk. My talk is more focused on the training the model from scratch, but still, I feel MLKit is very important for developers who want to use TensorFlow model on mobile. So MLKit has these ready-made services. For example, image label, OCR, face detection, barcode scanning, landmark detection. And for all of these, for those of you who have played with like Android's Vision API as part of the Google Play services, MLKit basically just used that Vision service, but combined it with Firebase. And with the help of Firebase, it offers some additional features in addition to the machine learning APIs. For example, dynamic model downloads. For those of you who are mobile developers, when you try to deploy your app, if your model has changed, you have to repackage your model into your APK for Android, right? And then try to republish it, which is kind of a pain. So with the MLKit, you don't have to do that. You can just do the dynamic model downloads. And it will also allow you to do the A/B testing and also the model compression and the conversion. As you know, when you run the model on mobile, on the mobile device, some of these models that has high accuracy, this also has very large size, and you don't want the size to be your model size to be too big. So MLKit offers this model compression and then a conversion from TensorFlow to Tflite. I believe the model compression and the conversion is either in beta or not out just yet. So I included a link here for you to check out MLKit. I noticed a lot of the Android GDGs have written excellent blog posts and give talks on MLKit. So you can easily just search online and find the resources there. Next, please. Next. So now I want to talk about the process of, assuming you're not doing like REST API call and using some ready-made thing, you actually need to train your model and put it on mobile. How would you go about doing that? Well, you will follow the process. You have to collect the data. You train your model, and you convert the model if you want a Tflite format, and then you will deploy for inference. And I want to talk a little bit about training versus inference for those of you who are new to machine learning. For those of you who have already done machine learning, this is no brainer. But for a beginner, you'll hear the word inference and you're wondering, okay, what's the difference between training and inference, right? So I'm going to give you an example, which is a very, very simple example of supervised machine learning for computer vision and its image classification. And in this case, when you try to train a model, you just feed in the labeled data. And when you try to train, the whole training process is basically finding a mathematical model that will describe the data. So, when we think about training, you think about someone is training to be play piano or active. When you train or you learn a language, training typically means you repeating the same task over and over, so you memorize it, so you get good at it, so that you can become an expert. But the machine learning training in this case is a bit different. It's actually trying to find that mathematical model that can describe the data that's not what you used for training. Okay. And then the inference is actually once you have that model, and you will use that model to predict a label. In this case, the label could be a digit, could be an image with a cat or with a dog on it. Next, please. First of all, data. There are existing data sets out there. Okay, for those of you who are new, getting started, if you pick any of the deep learning frameworks, such as TensorFlow, all the deep learning framework comes with these simple data sets. For example, MNIST, which are the digits. I will talk more about MNIST later, like CFAT10, CFAT 50, Fashion MNIST, IMDb Ruby reviews, etc., etc. And so because it comes as packaged as part of the framework, it's pretty easy to just, a couple lines of code, you can get hold of that data to write, and then you can move on writing the code for your model. There are also data sets on the internet that you can download. Even the MNIST, you can go ahead and download it. Right? Of course, if it already comes with the deep learning framework, you don't need to download it. But then I've listed out some other data sets here. How many of you have heard of Kaggle?
Oh, wow. Okay. 17? I didn't count.
So those of you who, down machine learning, you've heard of Kaggle. For those of you who haven't, check out this. Since I can't share my screen, I was planning on, toggling between different screens so that I can actually show you. But if you just go to kaggle.com, click on datasets, you will see there are tons of datasets there, which is really nice. A lot of these datasets are already pre-processed that you can just start using. And Kaggle is this platform for online machine learning competition. A lot of data scientists and machine learning people will go there to join the competition or sharpening their skills. So there's also data sets there. And then Google Dataset Search Tool. Sometimes when you search, you can go search in Google, right? Google.com. But it's not as nice as this new dataset search tool. If you use that search tool, it will return the results specifically for data scientists, for data sets, for your research. And so I talked about how to go about looking for data. Actually, there's also, instead of downloading existing nice data sets, you can also go scrape the data, the internet for data, but you have to also do some preprocessing on the data, which is part of collect your own data, which I'm not covering in my talk today, but understand that the data part is actually a much harder part than the optimizing of the algorithm part in many cases. Next, please. So machine learning models. I talk about this is do-it-yourself kind of process, but in this do-it-yourself kind of process, you could also just go ahead and download a pre-trained model. I included a link there for you. Some of these models like Inception, V3, MobileNet, and different nets there that you can use. MobileNet V2, you can use it running on a mobile device. Typically you want the model that's optimized for mobile device so that it sacrifices the accuracy slightly, but better performance, smaller size, and also better performance. When you try to train your own model, you can also use this thing called transfer learning. How many of you have heard about transfer learning?
8.
Okay, great. So transfer learning, for those of you who are new to machine learning, the analogy of transfer learning is like if you learn sports, if you know one type of sport, and for you to try to transfer to do another type of sport that's kind of similar, it would be very easy for you to pick up. So it's kind of similar there too, where the model has already, you can use somebody else's model, where in this network, the lower level layers pretty much are very similar, and they're not very specific features. So you can rely on that feature extraction or fine-tuning of the pre-trained models. To make transfer learning, actually, if you write transfer learning code with Keras or tf.Keras, it's fairly easy. But there's also tools to make this transfer learning process even easier. One thing is called the TensorFlow Hub. Another thing I did not include here is called Tensor to Tensor, all of which are trying to make this, the transfer learning much easier. Basically, in software engineering, you know how we can use somebody else's library, right? Reuse the code so you don't have to reinvent the wheel. And this is similar there as well. You just take that module, somebody else has written. And finally, train your own model from scratch. I've highlighted it here. The reason why I highlighted it here is because that's what I'm going to be talking about today. However, in the real world, unless you are a student who is studying machine learning or deep learning, or you are a researcher who's doing cutting-edge research, and in the real world, rarely people actually do everything from scratch. Typically people will rely on transfer learning, what people has already done out there. Next, please. So after we get a model, next step in terms of mobile is to deploy for inference. For mobile, when you have the model in the Tflite format, later on I will talk about the conversion part, and you will take that converted Tflite format and then you place it in your mobile app, and then for the inference, which in case of image classification, you can tell, whether it's a digit or what image it is, which I will discuss in more details later. Next, please. Next. So I want to talk a little bit about tools for deep learning. For us developers, people, engineers, like when you try to pick up, say, Android development or iOS development, you learn the framework, you learn the platform, you learn the language, and then you'll be wondering, okay, what IDE do I use to write my code, right? For Android, Android Studio. So I want to share with you the tools. First is Anaconda or Virtualize, which is not for writing code, but for creating virtual environments. I find virtual environments very helpful, very useful. And then I will just go over the Jupyter Notebook and Google Colab and PyCharm. Unfortunately, I can't show you since I cannot share my screen. Okay, I tried to click on share my screen. Still nothing. Okay, I will just talk through the slides then. Next.
Yeah.
But then my slides are fairly detailed, so it's okay.
Yeah.
Anaconda. How many of you heard about Anaconda?
Well, I would say 25. Lots of people.
Wow. Okay, great. Virtualize.
More like 12.
Okay, so more of you use Anaconda. Some of you use Virtualize. They're fairly similar. I included these commands here to how to download the Anaconda. In there's a package manager called Anaconda, which allows you to create a virtual environment, and then you activate the environment, and then you will install TensorFlow there, and then you will launch your Jupyter Notebook. And Virtualize, you will install Virtualize, and then you will create a new environment, you activate it, you can even deactivate it when you don't need it. Kind of similar there. So for TensorFlow 2.0, for those of you who are testing TensorFlow 2.0, please note, right now TensorFlow 2.0 preview, it is only available in Virtualize, not in Anaconda, not through Conda packaging. So as I mentioned earlier, I find that using a virtual environment is especially helpful for deep learning using TensorFlow, because TensorFlow moves rapidly. You write your code for one version, and then there's a bug for that version. You need to use the nightly, and you need to test the preview. You need to downgrade your earlier one because you have some problem. So virtual environment is the way to go. Next, please. So Jupyter Notebook. How many of you heard of Jupyter Notebook? It's probably a lot of you.
Yeah, like 25 again. Yeah.
Okay. So Jupyter Notebook actually interactive programming runs in the web browser. For those of you who don't know, it's great for visualization and collaboration. And if you're studying machine learning and deep learning, if you're a student, likely you will be using a Jupyter Notebook. Next, please. So Google Colab is basically Jupyter Notebook running on Google's VM in the cloud. Some of you have heard about Google Colab. If you haven't tried it out, definitely go out, try it out. I assume for those of you who come to the talk today, every single one of you is interested in learning machine learning and deep learning, right? Right? Interested? Raise your hand.
Yeah.
Everyone?
Not everyone. Some people did not. I don't know why.
So, okay, if you're not interested, I imagine you're probably interested in deploying the machine learning model on Android. You may not necessarily want to learn the machine learning model part, right? So, for those of you who want to learn machine learning and deep learning, check out Colab. The nice thing about Colab is that, yes, it's Jupyter Notebook, but you can it has free GPU and a free TPU. And TensorFlow is already installed, and you can save directly to GitHub. And then you can save and share from Google Drive, which makes collaboration also much easier as well. Aside from collaborating on GitHub, you can just collaborate with your friend or someone through just like a document in Drive, right? And then also, by the way, I would say all the tutorials I've written on TensorFlow.org is in the Google Colab format. So you can click on Lunch in Colab and then hit Lunch. So you can actually execute all the code through. Next, please. PyCharm is made by JetBrains, a very similar UI as Android Studio. So for those of you who are Android developers, you try to use PyCharm, it just feels like home, same UI. TensorFlow 2.0, eager execution, eager mode is going to be enabled by default. How many of you heard of eager mode?
2.5.
Oh, okay. How many of you heard about PyTorch?
Oh, a lot more. Like, I would say 20. Yeah.
How many of you use TensorFlow?
10-ish.
Great. So for those of you who know PyTorch, and some of you know both PyTorch and the TensorFlow, you will know the pain point with TensorFlow is the graph, the static graph instead of dynamic graph like PyTorch. So with eager mode, basically make the graph dynamic. And TensorFlow 2.0 is going to make the eager execution by default, which means, for those of you who don't know what I'm talking about, like eager execution, blah, 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 well, when you write code, you want to be able to set breakpoints and debug, right? But only when the eager execution mode is enabled that you can set the breakpoints and debug. And you can do so in PyCharm. Next, please. So now I'm going to talk about training a neural network with tf.Keras. Bear with me for those of you who already know machine learning. I'm walking through this simple example of MNIST for those of you who don't know. And I will also talk about model conversion, which you will find interesting even if you already know how to train a MNIST classifier. Next, please. So the MNIST data set has 60,000 training set and 10,000 test set. I've included a Colab, which you can look at later on in details and just run through the Colab yourself. Each of this image is 28 by 28. So the image size, width and height, 28 by 28 by 1. So that 1 indicates your color channel because it's a grayscale, so it's 1. And this is a multi-class classification. There are 10 classes going from the digit 0, 1 to 9, 2, 3, 4, 5, 6, 7, 8, 9. And this is a popular Hello World tutorial for computer vision, also for people who do more advanced machine learning algorithm, can also use the MNIST dataset as a benchmark in making sure everything is working. Next, please. So I've included a link. You can check it out later on. This is a Colab Jupyter Notebook that I wrote that you can just go over importing the data and defining a model, training a model. For those of you who already know those, but you might find the step of saving a Keras model and convert to Tflite interesting. Next, please. So here's a typical CNN model architecture. For those of you who don't know what a CNN is, it stands for Convolutional Neural Network. It's a way of, it's one type of deep neural network. I've included those definitions there for you to learn. If you learn a new, like a class, computer vision class with deep learning, they will go over these in more details. But if you look at my Colab, the model architecture, more or less, it will have the input, which is your image. If it's MNIST, it's a one image, which is 28 by 28 by 1. Your input is this pixel, which is 748 pixels. And you will feed through these networks. And these networks will stack as convolutional layer, a pooling layer, convolutional layer, pooling layer, etc., etc. Anyways, so it goes through this. It will allow you to detect the features of what is in the image. And then in the end, it will have this classification coming out. Basically, it will have 10 probabilities. In this case, we have 10 categories. And for each of the probability, let's say 0, digit 0, it might have a probability of a really, really low probability. If the digit is a 1, maybe a probability of 99 point something %. And then the other probabilities will be really, really low. And this is a really important point. Like when you try to do this classification on Android, when you try to run the inference, and that result that comes back as an array, it's in the format of this category, and for each category, what the probability is. Next, please. So you write the Keras code, tf.Keras code. There's ways of inspecting the model. One way to inspect the model with Keras is you just type model.summary, which will show you the model architecture in the Jupyter Notebook. That you will see the layer names, and then the output shape, and then the parameters, etc., etc. So the network input and output shape is extremely important. For those of you who have already done some deep learning, you probably know what I'm talking about. That a lot of times the error that you're getting when you train your model it will tell you like, oh, the tensor shape, blah, 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 something doesn't match. And for those of you who have worked on something like putting your model on Android, and a lot of times the challenge is also that input and output of the shape, of the tensor shape. So being able to inspect your model and visualize your model is super important. Next, please. So visualizing model, another way of visualizing a model, popular way is using TensorFlow. I didn't include the information here, but you can find tons of tutorials and information and documentation on TensorFlow. So just Google it, you'll find it. I do want to point out this tool called Netra. How many of you heard about Netra?
0.
Great. Okay. As I suspected, people don't know. So Netra, this is just somebody who wrote a library. I found it like super helpful in that if you ever use TensorFlow, you will see the network, the nodes and the operation, etc. Very complex. But so you can also write Python scripts to inspect every layer and shape and etc. But with Netra, you drag and drop your .tf model or your .pd, any model, any format of your model. You drop it into this Netra, which is a GUI tool, and then it will give you like a PNG file, like I included on my slide onto the right, which has information, helpful information for every layer of your network. Next, please. So now I'm going to talk about convert to TF model. Next. So Tflite, as I mentioned, that it's still in debug preview, and it works with Inception and the mobile net model. It may not support all the operations just yet. By operation, I mean when you do deep learning, in each of your network, there are these operations. So if there's an operation that when you try to do a conversion, you're going to see the error saying such and such operation is not supported. You can report to the TensorFlow team, and they will add the operation. So since the Tflite model got into preview last year, 2017 December, till now it's over a year, they have added a lot of the operations already. So hopefully you won't run into the not supported operations errors that often. And you can run Tflite on Android, iOS, Android Things, and the Raspberry Pi. Next, please. So to convert a Keras model to a Tflite model, you can either do the conversion through a command line or a Python API. I have included the documentation here for you for details. Next, please. So to convert the Tflite, the Keras model to a Tflite model through command line, this is assuming when you run your Python script or run the Colab, you have already saved a model, a Keras model, and then you just call Tflite _convert, and then specify the output file, and then the Keras model file, and then it will create that .tf model file for you to use for your mobile app. Next, please. So it is recommended that, although you can do that through command line, your model conversion through command line, it's recommended that you will do it through the API Python code. This is fairly new. Not too many people actually know about this. In fact, a lot of the things that I'm sharing with you today, you probably have a hard time finding in some documentations. So this is fairly new since the last new TensorFlow versions. a few months ago. The first step that you will create a converter, and notice that I have this control strike out. Instead of just change that word, I strike out the word control. The reason why I do that is it's very important to understand that as part of TensorFlow 2.0, the new version, one of the major changes that the Tflite is moving out of the control. In fact, the whole control from the TensorFlow GitHub is going to be gone. Everything out is going to be out of there to become either part of the core TensorFlow API or add-on or just some independent projects. And then you can just follow the rest of the code to create the Tflite model and then download that, use that Tflite model for your mobile application. Next. So testing the Tflite model. How many of you that know that you can actually test the Tflite model directly in Python before putting it in Android or mobile?
One very low hand.
Okay. As I suspected, people don't know how, and it's not easy. And I wrote code. I found this out because through my work, I found out, first of all, I struggled a lot trying to create a Tflite model like everybody else. A lot of people struggle with just to do that conversion and come up with a Tflite model. And after you struggle to get that model and you put it in your mobile app, and you continue to struggle. Like somehow that classifier is just not classified. Even though in your Python scripts, you test it, you validate it, it's 99% accuracy. When you put it on Android and iOS, the accuracy is 50% random. And you're wondering why. Things could be going wrong. Maybe you did your preprocessing code wrong. Something was going wrong in your mobile app, right? Well, the key is to test your Tflite model in Python before you put it in your mobile app. Because when you do so, then you eliminate all the guessing of your code in your mobile app as well, right? Because and how could it be that your model, your .pb or your Keras model is right, and then it's wrong after you convert to Tflite? Well, it's possible because bugs in the converter. And that's what I encountered. So the converter can be buggy. Sometimes the converter is going to tell you flat out that the operation is not supported. Sometimes it will spit out a .tflite model file for you, and you will take that file and it's not going to work. But anyway, so this is how you will test, and you will use this interpreter that's from the Tflite API. And you have to manipulate your data to feeding the data exactly the same as what your training data is. And then you can do a testing just to verify that accuracy is exactly the same as for the conversion. Next. Okay, so now I talked about how to train the model from scratch. I went through the MNIST really quick, talk about the model conversion. Now you have a Tflite model. Tflite, sorry, that's actually a typo. It's .tflite model, not Tflite. So you have this .tflite model file, and you're going to place it under the assets folder if it's Android. And then you're going to update the build-up Gradle. And then you're going to have an input image. You will do pre-processing, and then you will run the inference to classify the image with the model. And then you'll do some post-processing, and then you will display the result in the UI. Next. So for those of you who know Android, here is you're basically adding the dependency to the TensorFlow Lite wrapper, and you're also setting the configuration to be that when your app is compiled, the model itself does not get compiled. You also, as I mentioned earlier, you will put your model file onto the assets folder. Next. And you will have an input image in case of image classification. And how do you get that image? Is in case of Android, you can draw on canvas from a custom view, which in my sample app, I wrote a sample app for the MNIST, which is the custom view. You actually draw a digit on the canvas. You can also get that image from gallery or a third-party camera, which is easy. You just simply launch by intent. Go to a camera, take a picture, come back, you have that bitmap, and then you can work with the bitmap. You can also work with live frames from camera to API. And the option of using the live frames, that part is it's harder because you have to worry about the performance and you have to dealing with these multiple frames coming in instead of just one static image. Also, keep in mind, I understand not everyone of you in the audience is Android developer, right? You might be iOS developer, you might do IoT, etc. But the process is similar. You basically need that image frame as an input. And also you need to make sure that your image dimension, the shape will match what your classifier expects, right? So when you look at the TensorFlow code or the tf.Keras code, and that code, if the training code is expecting a 28 by 28 by 1 and this data, then your input, your Android app better be 28 by 28 by 1. If you're using Inception V3 model, it's 299 by 299 by 3. And that 3 is the color channel. So if it's a color image is 3, it's a grayscale is 1. And then for MobileNet, it's 256 by 256. Right? Next. And then you will see in my sample code, which I will include the link there, the Android sample code, which you will see you need to do image preprocessing. You need to convert the bitmap to a byte buffer. And after that, you basically have all these pixels. So in the image, that every single pixel needs to be fed in as an input. And for the color, there are 255 colors, and then you divide that by 255. You basically normalize your pixel values for a certain range. So that normalization is similar when you try to train your machine learning model. You need to normalize, and here we're in Android. So when you're feeding an input, you also need to make sure the pixel values is normalized. And you need to convert from a color to grayscale. Let's say you are, for example, let's say if your machine learning model on barcode is trained on grayscale, and you have this camera is collecting live image, which is color. Well, in that case, you need to convert from color to grayscale in your app. Next. And then you will load the model file and then use that interpreter to run the inference on the input image. Next. And after you run that interpreter, the result that comes back is actually an array of probabilities in case of digits. If you try out the Google official sample, they know how to classify 1,000 images. It also comes back as, a list of these probabilities. And you basically just need to find out the category or the class that has the highest probability, and then you output that result to the UI. So, for example, in this case, I drew with my hand an 8. When I click on that classify button, it will predict number 8. Well, that output result is actually will be in a format of 0 has this probability, and 1 has this probability, and 2 has this probability, etc., etc. And then 8 has the highest probability, and we will output that to the UI for the user. Next. So what I've gone through is a sample app I put together. I will include the link. You can download it from my GitHub. That one is to train MNIST and then do the digits. And I'm including here, this is the official Google's TensorFlow Lite demo app. If you clone TensorFlow project from GitHub and you just go to their Lite Java demo, and you will see you can run this app, that you will see that it can detect like 1,000 different type of objects. However, it is not trained on human. If you point that app in front of the audience and human, I don't think they will know what it is. So sometimes, when I do live demo, I will point it in the audience and I will do some foolishness. I will not know. And this app uses live frame. It's a bit more complex because, the camera API, camera 2 API has lots of code and 1,000 lines of code there. And also it has like multiple threading, neural networks, API, etc. So, much more complex. But it's similar in that simple app that I showed you earlier. It's all similar in that you will find the model file under the assets folder. It's similar how it defines the dependency in the Gradle and set not to compress a model file. It's also similar. It's going to have like a classifier class, and it means you also need to define the input width, height, channel, etc., etc. Next, please. So challenges. I went through a very simple app, and I share with you the official app that's more complex, that can detect more classes, and you probably want to try out doing your own, right? Train your own image classifier, or not classifier, but doing other things like object detection, etc., etc. Well, here are the challenges. In my opinion, Tflite, using Tflite on Android is not easy. I have worked on Android since 2012. I have worked on machine learning for the past 3 years. I know both very well. And for me, I still struggle with making sure the image processing code is correct, making sure the input tensor shape is correct, making sure post-processing is. It's just very challenging. I heard other people I know, when they use CoreML for iOS, it sounds like it's easier. And I would say the TensorFlow team is working really hard, trying to make the process of, for example, of the auto conversion, what I just showed you. Very simple code of converting from Keras model to Tflite, right? That's pretty easy. But before those APIs were written, trying to do a conversion was a nightmare. So that got easier. And I just wish that the code on Android becomes easier for us, right? And I also believe with the ML kit, it will make both, whether you use the ready-made API or try to use your own custom model, and hopefully life will become easier. Next. So that's it, my talk. And please follow me on Twitter, Medium, or GitHub. I will make sure you get the links of the TensorFlow code, or the Keras code that I shared with you today, as well as the Anchor code I shared with you. And I will open for questions.
Okay, I'm going to switch to the Hangout since Maybe easier to see your face.
Okay.
All right. Okay, stop screen sharing. Okay, questions? Yeah. Okay, I only heard half of the words. Can you speak louder? Yeah. So the question was, does the converter support converting custom models or only from Keras?
Yes, custom models as well. I only went through the example from Keras. You just go to that converter documentation page. You can convert from the same model.
Okay. Any other question? Yes. Dart, yeah. Okay. Mm-hmm. Okay. So I think, yeah. Can you hear the question?
No.
Okay, I will repeat the question. Yeah, so basically he's asking about your opinion on using Dart and Flutter with TensorFlow. Is that a good summary?
Oh.
Yeah, have you used it? Yeah.
Okay. So my opinion is, I'm a GDG organizer. I ran Flutter study jam already. And I would say it is still quite early if you want to use Flutter with TensorFlow. Last I heard that the Flutter team was going to write some sample code of TensorFlow with Flutter. I don't know if that's out yet or not. I'm pretty sure they have plans to have machine learning with Flutter, but early, very early.
Yeah, so he said he saw the documentation, but he's wondering if you had a chance to play with it yet.
Oh, so no, I have not.
Okay. Okay. So thank you so much, Margaret. This has been great. There was one more question. Hold on. Yeah.
Okay.
The question was, how many apps in the Google Play Store uses TensorFlow? Or Google Apps.
Oh, I don't know off the top of my head, but I would say, I could be wrong, but I would say most of the Google apps have intelligence and they use TensorFlow Lite. Yeah, majority of them.
Okay. Right. Last chance.
Any other questions?
Any questions? Can we see your cat? Is my question. We heard it.
Are you sure?
No, that's just a joke, because we heard some meowing, so we were wondering if we can classify that as a cat.
Yeah, but sound.
Yeah. All right. Well, thank you so much, Margaret. It's been great just to be able to get you to speak to us, even though you are not here in Boulder. So thank you so much.
Yeah, thank you very much. Thanks, everyone.
All right.